Today, as the next topic, let us discuss a horizontal projectile. Let us first understand what a horizontal projectile is. A projectile which is projected horizontally, as the name suggests. So, if there is this body which is just given an initial velocity which is along the horizontal u, would be a project, and then after that we allow it to move under the effect of gravity. But if it has to move under the effect of gravity, in this initial situation, it will always tend to move down like this, isn't it? For which we need to first make sure that we are projecting it from a certain height. So, this projectile initially is kept at a certain height from the ground, and it is only from that height that it is projected down. So, this is the situation, this is the ground level, and from the top of, let's say, a building or a tower of height h, a body is given an initial velocity u which is all along the horizontal. But we understand that as this body falls down, gravity works on it and it will take a path which will look like this. As it falls down, it will gain velocity in the downward direction also because of the gravitational acceleration. And finally, when it reaches the ground, it will have both the velocity components along the x-axis as well as along the y-axis. As this projectile moves, understand that it does not suffer any acceleration along the x-axis because there is no force along the x-axis. The only acceleration that it suffers is downward along the vertically downward direction, which is equal to g, right? And in case we take the upward direction to be positive, can we say that this acceleration will be minus g? Let us take the vertically upward direction as the y-axis, positive y-axis. Then the acceleration along the y direction will be minus g, thereby telling us that the acceleration is pointing in the negative y direction. Along the horizontal, which we have taken as the x-axis, there is no acceleration. So, once again, we see this projectile and its motion as a combination of two independent motions, one along the x-axis with no acceleration, that means it will be a uniform motion, and the other along the y-axis, which is a uniformly accelerated motion with a constant acceleration of g acting downwards, right? So, we can once again do the same thing that we did in a standard projectile. We can split this motion into two parts and work separately using the equations of motion along both. So, along the x-axis, we know that the initial velocity along the x-axis is all the initial velocity that the projectile has. All the u is along the x direction, isn't it? So, ux will be nothing but u, whereas the acceleration along the x-axis is 0, whereas along the y-axis, the initial velocity is 0, no initial velocity along the y direction, whereas acceleration along the y direction is minus g, minus sign is for the downward direction. And now we try to use the equations of motion along both the directions. So, the first equation of motion, Vx is equal to ux plus ax into t, will give us, because ax is 0, it will give us Vx is equal to ux, which is nothing but u. So, we understand the same thing that we have discussed in the normal projectile also. Along the x direction, it is a uniform motion. Along the x direction, the velocity does not change. In fact, if we try to draw the velocity vector at any intermediate point v, and if we try to take its x directional component, this Vx will always be equal to u, irrespective of the position where you try to find it out. Let us call this equation number 1. Similar equation when we use along the y-axis, the first equation, Vy is equal to uy plus ayt, this will give us Vy is equal to, because uy is 0 now, you will have 0 plus and ay is minus g. So, Vy is minus g into t. What is this equation telling us? It is telling us that the velocity along the y direction increases in the downward direction as time increases. As t proceeds, velocity becomes more and more negative along the y direction. Second equation, along the x-axis, s is equal to ut plus half at squared will give us x is equal to uxt plus half axt squared. Once again, since ax is 0, This will give us a simplified equation as x is equal to u into t. Ux is u. So an equation similar to distance is equal to speed into time, which is an equation for uniform motion, which we know is there for the x-axis, motion along the x-axis. Along the y-axis, the same equation will give us y is equal to uyt plus half ayt squared, which will give us, because uy is 0 this time, y is equal to minus half gt squared. The minus sign comes from ay is negative. So this is a quadratic equation, right? Let's call this equation number 4 here, and this is a quadratic equation in t. Y depends upon square of t, so it will be a curved graph. We shall see that later, that it's actually a parabolic graph. The third equation of motion along the x-axis will not give us anything new, any new information, so we won't use it there. We'll directly use it along the y-axis. Vy squared is equal to uy squared plus 2 times ay into y. This equation will give us Vy squared is equal to 0 minus 2gy, an equation connecting the y directional velocity with the y directional displacement, right? So we've got the same set of 5 equations as we had obtained in a normal projectile, just to work for the quantities that we would now try to find out for this projectile. So the first thing that we can now try to find out here would be the same as we got for a normal projectile, that's time of flight. That's the total time that the projectile stays in air for, right? The time that it takes to fall from the point starting position, let's call it A, to the final position on the ground B. What condition can we use to find out the time that this projectile takes to reach to the ground? See that as it moves from the position A to B, the y directional displacement that the projectile has will be h. As it moves from A to B, this will be the net displacement AB, right, whose y directional component will be h, because h is the height from which the projectile has been thrown, right. So can we say that as the projectile reaches from the point A to the point B, its y directional displacement will be h. So if we can use the fourth equation of motion, this equation, the one that connects the y directional displacement with time, and put y is equal to minus h here. Why minus h? Because we have taken upward direction to be positive, and the displacement that the projectile undergoes is along the downward direction. So we have to put it along with the correct sign, right? So y is equal to minus h we put in equation number 4 to get the corresponding value of time, the time for which this happens, which will be nothing but the time of flight. So when we do that, y is equal to minus half gt squared will become minus h is equal to minus half gt squared, and this t will now be capital T, the time of flight. So we can write it as capital T is equal to, when we solve this equation, the minus signs will go away, and g by 2 if we take on the left hand side, we'll get 2h by g, and then it will be a square root of that, because we have a t squared on the right side initially. So this becomes then the expression for time of flight of the projectile, the time that the projectile takes to reach to the ground from the point A. Do we remember this expression? We have worked upon this expression earlier also, root of 2h by g. What is this expression? If you look carefully, this expression is nothing but the same time that a particle which is dropped, simply dropped from a height h, will take to reach to the ground. If there is another particle over here which is dropped with an initial velocity 0 and simply allowed to fall down under the effect of Earth's gravity, it will take the same time t is equal to root of 2h by g. This we have calculated using the equations of motion when we were discussing the motion in a straight line, right. The same time comes there also for that particle also. So what do we understand from here is that a horizontal projectile and a normal particle which is dropped from the same height, they have the same y directional motion. Why? Because in case of a horizontal projectile also the initial y directional velocity is 0, isn't it? So the y directional displacement of this horizontal projectile becomes identical to that of this particular particle which is dropped simply from the same height. From here we understand how the x and the y directional motions of projectiles are actually independent of each other. They do not affect each other in any way, right? So this is about the time of flight. The next thing that we would like to find out here would be the horizontal range. So as we have discussed in the previous video also, for a normal projectile, horizontal range essentially will be the distance that the projectile has travelled along the horizontal, this length. If we call O to be the base of the point from where the particle is projected on the ground, the distance OB is the horizontal range R, right? Now how do we get it? Do you see that the horizontal range is nothing but the horizontal displacement of the projectile in a time when it completes its motion in the time of flight. So if we just put t, the time, as time of flight in the equation that connects the x directional displacement with the time, we will be able to get the horizontal range, isn't it? Which is here equation number 3. So let's use that. Here we put t is equal to capital T, the time of flight, in equation number 3, which implies x is equal to u into capital T, and now this x will become the horizontal range, right? So we can write it as capital R is equal to u times capital T, whose value we have just now found, root of 2h by g. So we can substitute it. This becomes the horizontal range. It's not a formula, essentially it's just the basic equation, distance is equal to speed into time, that we are using here. So you can just remember it as an expression from there. It's not a standard formula in any way to be remembered or by hearted. Okay. One more thing that we can try and find out here would be the velocity of this projectile at any point in time, right? Do you see, as the projectile moves in air, it gains more and more velocity along the y direction. So if we consider this velocity at any intermediate point of the projectile's motion, it will have two components to it. One is the x directional component and one will be the y directional component. We now know that the x directional component of velocity does not change with time, it always remains u, whereas the y directional component of velocity we can calculate from this equation, equation number 2 that we have written here. And once we know both the components, we can combine them together using the vector laws to get the final velocity also, right? So when we try and do that to get the final velocity, or velocity at any time for that matter, velocity at any time t, can we say that we can write that velocity as vector v is equal to vx I cap plus vy j cap in the vector form, where we know that vx will always be the same as u, initial velocity, and vy will come from the second equation, vy is minus gt. Let us use that here, right? So when we substitute these components here, we will get the final velocity as u I cap minus gt j cap. The minus sign here we all understand now, tells us that the velocity is along the vertical downward direction. We can also find out the magnitude of this velocity, right? We know this is how we will get the magnitude, u squared plus minus gt whole squared, which will, where the minus sign will then cancel out when we square it up. In fact, we can also find out the angle, the direction of this velocity. Understand that the velocity will be somewhat like this, in this direction, like this, and it will have two components, one component along the x axis vx and the other component along the y direction vy, and we can say that if phi is the angle that the velocity vector makes with the vx direction, then we can combine them together, knowing that this length is vx, this length is Vy, we can write tan phi is equal to Vy by Vx. So, we can substitute these values here. Vy we know is Gt and Vx is u. I have omitted the minus sign here because we know that we are already taking the angle phi below the horizontal axis, right. So, the minus sign we do not have to put here now anymore. So, that way we can get every information about the velocity of this projectile. One more thing that we can look for maybe would be the equation of trajectory of the projectile. Equation of trajectory, as we found it for a normal projectile, equation of trajectory actually connects the x and the y coordinates together, so that we get the equation of the path that the projectile takes. So, for that, once again if we go up, we have one equation which connects x with time, x is equal to ut, and one more equation which connects y with time, y is equal to minus half gt squared, equation number 3 and 4. We can use these to eliminate time out of these two and get the equation of trajectory. Let us do that. X is equal to ut and y is equal to minus half gt squared. From these equations, from the first equation we get t is equal to x by u, and we use this t value in this equation to get y is equal to minus half g into x squared by u squared. This becomes our equation of trajectory, simply an equation that connects the x and the y axis. Once again, minus sign is telling us that the y coordinate of the projectile will always be negative, because if we consider the starting position as the origin, so point A is considered as the origin, after that we know that the projectile moves only downwards, and since we have taken upward direction positive, that means the displacement along the y direction will always be negative. That is why this constant minus sign we have, right. So, these are a few basic aspects associated with a horizontal projectile. We can now look at a couple of examples to make our basics stronger here. So, the first example that we have is, a ball is thrown horizontally from the top of a tower with a velocity of 20 meters per second. So, this is the situation. 20 meter per second is the initial velocity given to a ball, which is thrown from the height of a certain tower, whose height is not given to us, by the way. During its motion at a particular point, it is given that the horizontal and the vertical velocities of this projectile become equal. We are supposed to find out the time elapsed to reach this point, time when Vx becomes equal to Vy, and also the displacement of the particle at the same time, at this time. Okay. So, do we understand the question? Do we see that as this projectile falls down like this, its y directional velocity will keep on increasing in the downward direction, whereas the x directional velocity will always remain the same, 20 meters per second. This is Vx at all the times, whereas Vy keeps on increasing in the downward direction in such a way so that Vy is given by Gt in the downward direction. This time if we take downward direction positive, we can consider G to be positive. So, Vy will be plus Gt now, right. So, if we want Vx to be equal to Vy, does that mean that 20 should be equal to Gt, and from here we can get the value of t. T will be 20 by G, that is 10, taking the value of G as 10 meter per second squared. So, we get 2 seconds as the value of the time. That is our first answer to the first part. In 2 seconds, the velocity of the projectile will have same magnitudes for x and the y components of velocities. Now, how to find out the displacement at this time? Let us say this happens over here somewhere at this point, call it B, the starting position is A. What is the displacement from A to B? Can we say it is the straight line vector joining the positions A and B like this? And can we say this vector will have its own two components? One is this horizontal component, which will be nothing but the x displacement, the x directional displacement of the projectile, and the other would be the downward displacement like this, which will be the y directional displacement. So if we can find out both of these displacements along the x and the y direction, then we can use trigonometry here to find the total displacement length AB. Yeah. So how do we do this? For the x directional displacement, we can say that along the x axis, the particle moves with a uniform velocity of u, the initial velocity, and if we are looking for its displacement in a time t, u into t will simply give us the displacement, right? So u is given to be 20 and t we have just now found is 2 seconds. So this gives us 40 meters as the displacement along the x axis. Whereas along the y axis, the displacement equation is slightly different. It is ut plus half at squared, where u is 0 for the y direction, right? So along the y direction, the displacement will be half gt squared. Half at squared will become half gt squared because acceleration is equal to g. And since we have taken downward direction positive, we'll be writing plus g here instead of minus g. So no minus sign here this time. And now we substitute the values. Half g is 10 t squared. Solve it to get 20 meters as the y directional displacement. And then just by looking at the figure, we understand that the length AB, which is nothing but the magnitude of the displacement, will be square root of x squared plus y squared, which will be square root of 40 squared plus 20 squared. Solve this to get 20 root 5 as the final answer, 20 root 5 meters. We can also find out the direction of the displacement to get all the information about it. Maybe we can try finding out this angle. Let's call this angle phi as the angle that the displacement vector AB makes with the horizontal direction. We can write tan phi is equal to, see, understand that this angle will also be phi then, and then we can write tan phi is equal to y by x, opposite by the base in this particular right angle triangle. So y by x, which will be 20 by 40, 1 by 2. So phi is equal to tan inverse of 1 by 2 becomes the direction of this displacement, right? So we have just now expressed our displacement in terms of its magnitude and the direction. We could have also expressed the complete displacement vector just by taking the components itself, writing it in the component form, xi cap plus yj cap simply. In that form, the answer would be 40 meters I cap plus 20 meters j cap.